So, good morning, everybody. Myself, Acharya Vishvendra. Let's discuss today uh, one of the topic of modern physics, which is atomic models. So, let's start. So, the first atomic model that we are going to study is Rutherfords atomic model. Although, if we study historically, you must have studied in class 9 that first atomic model was Thomson's atomic model. So that is very basic. So we'll start with Rutherford's atomic model as per class 12 is concerned. So there are certain postulates. Postulates is that most of the mass and positive charge is concentrated at the center. This is the first postulate. Second is electrons, which are negatively charged particles, revolve about nucleus in circular orbits. This is the second postulate over here. Now there are certain limitations of this model. Limitations are it is unable to explain the stability of atom, and second is unable to explain line spectrum of atoms. So concerning with the stability, suppose that an electron is revolving around a nucleus. So electron is a charge, so it will emit electromagnetic waves and it will lose energy, because of which its speed will decrease, and if speed decreases then it will form a spiral path and will ultimately fall into the center. So atom should collapse. And the second thing is that it is unable to explain line spectrum of atoms, because as electron is continuously accelerated, so its speed and frequency of revolution is continuously changing. And as per the classical electromagnetic wave theory, the frequency of electromagnetic waves created by a charge is equal to the frequency of oscillation of that charge. So, as per the Rutherford's atomic model, the line spectrum should not exist, it should be a continuous spectrum. But it's well proved by experiments that elements emit line spectrum like that of famous hydrogen spectrum comprising of Lyman, Balmer, Paschen, Beckett, Pfund and Humphrey series. So these were the limitations concerned with this atomic model, that it was unable to explain the stability of the atoms. Now, to explain these limitations, Neil Bohr proposed an atomic model. And according to him, an electron can only revolve in certain specific orbits without radiating any energy. And these orbits are called stationary states. So he just proposed that electron just revolve only in certain specific orbits without radiating energy. So if it is not radiating energy, then the question of falling into the nucleus is well explained. Second postulate is that angular momentum of the electron moving in a stationary orbit is quantized, which he gave that angular momentum is L, which is mvr, which is nh by 2 pi, and n corresponds to the principal quantum number of that particular state of electron. Now there is a third postulate which says that an electron can make a transition from one of the stationary state to another stationary state by emitting or absorbing photons of a specific frequency, having energy equal to the magnitude of the energy difference between the two states. So suppose that this is energy state EI, this is energy state EF. So two possibilities are there. If a specific frequency photon is given to EF, it may transit to the higher energy state EI. And another possibility is that electron may undergo transition from higher to the lower energy state and when it will do so, it will emit a photon of a specific frequency given by h nu, its energy given by h nu. So these were the postulates of Bohr's atomic model, but it had got certain limitations also. And the first limitation was that it is applicable only for hydrogenic atoms, that is single electronic species. And second is that it is unable to explain the relative intensity of lines in the spectrum. Actually, if you observe the spectrum of hydrogen atom, then certain transitions are preferred over other transitions, and those preferred transition are from a smaller energy gap, and generally the energy transitions corresponding to higher energy gaps are less. So this was not explained by Bohr's atomic model. Now let's study certain parameters related to that. So suppose an electron is moving in a certain energy state of hydrogen atom, then suppose this is the nucleus and an electron is revolving around it with a, let us say, speed v, radius r. So there are certain parameters of that. The first is radius of nth orbit. The radius of nth orbit is given by n square by z into r naught, where r naught is 0.529 angstrom. So from here we can analyze that r is proportional to n square. So the ratio of radii of consecutive energy states will be in the ratio of 1:4:9, that we can mathematically analyze from this. And another thing is that there is one more concept, that if we analyze the exact expression for this, so the exact expression is r naught is equal to epsilon naught h square pi m e square, where h is the Planck's constant, m is mass of electron, e is the charge on electron, and e naught is permittivity of free space. Another parameter is that of speed. So using conservation of quantization of angular momentum, mvr is h by 2 pi, we get v naught is equal to this. So this is equal to this. So v as a function of n is v naught z by n, where v naught is c by 137, which is about 2.1 into 10 is to power 6 meter per second, where c is the speed of light in vacuum, which is 3 into 10 is to power 8 meter per second. So v is proportional to 1 by n. So if we compare the speed of electrons in different orbits, then it will be 1:1 by 2:1 by 3, which is 6:3:2. These are the ratios of speeds. That means larger the distance from the center, lesser will be the speed. Next is time period of revolution of electron. So this time period is 2 pi rn by vn. After calculations, we get t is equal to t naught n cube by z square, where t naught is 1.58 into 10 is to power minus 16 second. Next is energy. So kinetic energy, after all the calculations, it comes out to be k naught z square by n square, where k naught is 13.6 electron volt, which is 21.76 into 10 is to power minus 19 joule, which is 2.176 into 10 is to power minus 19 joule. And in terms of mass of electron, it is equal to this. Then we have potential energy. So potential energy is actually double of this. Then we have total energy, which is equal to this. Then we have frequency of photons. So using h nu is equal to ei minus ef, the final result comes out to be this. And this is r, the Rydberg constant. So in this way we have calculated certain parameters based on the atomic models. So let's revise the entire thing. We studied about Rutherfords model, then Bohr's model, then certain parameters related to the Bohr's model. And in your exam, the most probable questions are from the parameters of electrons. So we'll continue in the next video. Thank you. Have a nice